Good morning, everybody. Thank you for joining me today. Thank you for watching, whether you're watching live with me or you're watching the recording. I just appreciate you watching. So, welcome to our second live stream of the summer semester. Things are off to a great start so far. I'm in the process of looking over your Module 1 essays now, which is awesome, right? I've been looking through, I've just had the opportunity to kind of read through a couple of them so far. But what I'm seeing so far, I'm really liking. I also had the opportunity to grade your discussion boards already. And by and large, I was really impressed by what I saw in the Module 1 discussion boards. I think you all did, by and large, excellent on that first discussion board, and that's something that, we'd like to see carried going forward. So let's not lose that energy as the semester progresses. That's one of the things that is prone to happen, right? Like, we start the semester all excited, and then by the time we get to the end of it, we're a little burned out, we're a little tired. We just want to make sure that we keep that energy up and we keep that energy going all summer long. I also noticed that a couple of you have already gotten a nice head start on Module 2. Like I told you all last week, that's perfectly fine. That's why I have all the modules open at once. So you can do things like that. I especially like to do that during summer semesters because, you might want to dip out for a week and take a vacation. Right? So if you can go ahead and work ahead, then you don't have to worry about anything for a week and you can just come back and jump right back in. So don't mind you working ahead. That's fine. We're just going to stay on the path that we have, though, provided by our due dates and such. And so far, so good, right? And so if it's not good, let me know. Right? I want to try to, make sure everything goes smoothly this summer. And so this week we're talking about how the internet works. And I'm just going to go ahead and warn you straight up front that this is a very simplified version of how the internet works, right? Like, we're going to get into the weeds with some things. But I'm going to go ahead and tell you right off the jump that I'm not expecting a whole bunch of stuff here. Right? Like, when you get it, like, for some of you, especially those of you taking, networking degrees and such, you're going to get into the weeds of networking and you're going to see how this all works in much greater detail. Right? And so what I'm primarily talking about here when I'm talking about how the internet works is mostly just how the internet works in such a way that it is important to us as developers, as programmers, as data analysts. Right? So what we care about is a much more shallow field than, what somebody might care about if they were a networker, if they were actually making sure all these different parts spoke to one another. Right? And when it comes to the 3 degree paths that we have at CCC, the programming and web development track, the networking track, and the cybersecurity track, I always like to tell people, well, programming, that's computer's language, right? That's how a computer talks, right? And how we can talk to a computer. And then networking, that's how computers can talk to one another. So if programming is how we can talk to a computer, networking is how computers can talk to one another. And then cybersecurity is about making sure all those discussions stay private. Right? So if we wanted to take the 3 disciplines and kind of truncate them down, we could talk about them in that sort of way. And so this module in particular does kind of touch in some other areas. But we're not going to go deep into them. I'm not expecting deep, thorough understanding of how the internet works. I just, I want to see that you have an understanding of the basic path of what happens from when you enter in a URL, like www.clevelandcc.edu. When you enter that into the browser, what is going on behind the scenes in the amount of time that it takes for you to get that website back. Right, and so I am going to cruise through just some definitions here. Right, so we can get through the meat and potatoes here. The server. I want to talk about the server really quickly just because the server is pretty critical. For what we're doing here. And let me just go ahead and make sure that I have everything kind of pulled up here so I can see if questions get asked through any means outside of YouTube chat. So again, as you're kind of following along, if you have questions, ideally drop them in the YouTube chat, but you can also send them to me through email or through a Teams message as we're kind of progressing, and I will do my best to monitor all of these so that we can answer them. But the server, that's the big piece of hardware that we're concerning ourselves with, is the server. And so as we're starting to think about, well, how the internet works, how does the internet work, we got to think about the server, because the server is kind of the lifeblood. I often talk about the server as being kind of the house. That's where the website lives. right? The website lives on a server. So when we're making our request, which we'll talk more about in just a few minutes, it's basically like we're visiting their house, right? Or we're kind of asking who lives at this house. And so the server is where all the files for our different websites live, right? Like in order to have a website, I need to have a server and I need to upload files onto a server that are going to get served, that are going to get sent to you. Right, and I think a lot of times we like to kind of mysticize servers, right? Like if you go by the data center here at Cleveland Community College, like you see a big room with a lot of servers in it. There are a lot of blinking lights. There are also, other bits of equipment in there like routers and switches and firewalls and all that kind of stuff. But you see these big things, and we kind of have the picture in our mind of these rack servers, which look like this, right? We have a rack server where we have several of these in a rack. And, kind of in movies and in television and maybe in our mind's eye, right? Like that's the picture that we have of a server, are these big racks filled with these rack servers with all sorts of blinking lights. And they look super complicated and they look, fancy. But really at the end of the day, right? And especially it's something that you'll find out if you've done any sort of networking before or if you're in the networking program, or I think the cybersecurity program also for that matter. These servers are just big computers. Big computers with a lot of hard drive space. Right? We just kind of reconfigured them to where we could put a lot of hard drives in them for a lot of storage. And, we put a lot of good hardware in them and we oriented them to where we could fit a lot of them in a small space. And so it's just a computer, just like your laptop's a computer or your desktop's a computer, right? Like if you interact with one, especially if it has like Windows Server on it, you'll notice that it looks really similar to just a regular old Windows PC when you log into that server on the back end. Right? What makes it special is the software on it and the kind of hardware that's in it. Right, the specific types of hard drives, the specific types of things that's inside that allows it to do what it does. Right, and so when we get a bunch of servers in a room, what we could have there would be a cloud. You've probably heard a lot about the cloud, AWS, Google Cloud, Azure. Things are stored in the cloud. And I think that's another thing that we, by and large, sort of mysticize, right? Is we have this idea of the cloud as just being some sort of ephemeral place where data goes. But there is no such thing as an ephemeral place where data goes, right? Like data has to go somewhere, it has to live somewhere, and it has to live somewhere that can follow that data cycle that we were talking about last week, right? That can take data, run it through a process, and pull it back out to become information. And we said computers do a data cycle. So if the cloud needs to store data and data needs to be run through a data cycle, then the cloud is really just a bunch of computers. So you might have seen like memes and stuff before that say like, oh, there is no cloud, it's just someone else's computer. And really that's accurate, right? It is accurate that, it's just a fancy word for just basically somebody else's computer that you can access via the internet. It's just a server. Right, and so there are different kinds of servers. I won't go through them here. I won't go into much detail here just because I do go into, I believe, a little more detail on this in the module. But there are your desktop servers. Desktop servers, right, those look pretty familiar, right? They look like just a standard desktop tower PC. Now you could probably, you might be able to discern here by the picture that we have here that they're a little bit bigger than your standard desktop servers. Your micro ATX, your mini ATX chassis aren't going to be able to hold the required hardware to be an adequate server, but you can just create a server out of just a regular old desktop PC. Might not last long, right? If you're running it at production capacity, it might burn out the processor or kill the hard drive or something of that nature. But you can just take a regular old desktop, install a server operating system on it, and serve files off of it. Some people do Minecraft servers this way. You can do simple web serving this way for websites, right? It's not recommended. You'd always prefer a server, even if it is something like a desktop server here, over just a standard PC, but you could do it. We looked at our rack server. There's also the blade server. The blade server is kind of the natural evolution of the rack server. Thinner, a little more expensive. And the big thing with the blade server is that it's hot swappable with the blades that are in it. So if one fails, it's got redundancy built in, and I can just pull out one blade, push back in another blade, easy peasy, and it does its redundancy cloning, and it's back in action at full capacity relatively quickly. So where we really start caring about what happens with the server is right here, and that's with server software. Right, in web development, we call these stacks, right? These are software stacks. And we see one example of a software stack here, which is the LAMP server. LAMP could also, you could read it as MAMP or WAMP. Like, these are different variations of the same thing, right? So so what we have here in our picture is a depiction of a LAMP stack, but there are also MAMP stacks and WAMP stacks that go along these same lines. And a stack just describes what the software is on the server that's helping it do its job. Right, and this is going to vary based on the applications that are being hosted on any given server, right? But the general components of our stack are going to be universal. Just the type of these general components, the specific type of these general components is what's going to vary. We see here our LAMP stack is Linux, Apache, MySQL, and then some sort of backend language like PHP or Perl or Python. Right, so in this case, the LAMP stack uses Linux. That's the L in LAMP, right, is Linux. And that's just the operating system. Right, the Linux operating system, it could be any flavor of Linux operating system. It could be Ubuntu, it could be Debian, it could be Red Hat, it could be Pop! OS, it could be whatever Linux distro you like. Right, you run it on your server as a server operating system, and it's the operating system for the server. And then there are other layers that go along with our operating system that help the server be the server. For instance, Apache. Right, Apache is what facilitates the communication. Apache is what facilitates our hypertext transfer protocols, our HTTP. So that's the layer that's handling all the communication from the server to you. Apache does a few other things, but it's mostly, for our purposes, it's mostly just handling your request and sending back a response. MySQL, that's the database. So Apache is the A in LAMP. MySQL is the M in LAMP. It is just the database. That's where all the data is stored. And so typically what we do is we will sort of put an obfuscation layer between the data and the website. And this helps us secure data. maintain integrity of data, things of that nature, right? Because we have it in a separate layer that can be accessed by the website backend code. But not readily available in just plain text everywhere, because some things that a database has, we want to keep private. Other things might be able to be public, but we want to be able to manage that. So we put that in a separate layer. And in this case, it's MySQL, right? And there are a bunch of different types of databases. We'll talk about that on another slide here. But it's basically just where our data is held. And then we have our backend language. And in this case, our P could be PHP, Perl, or Python. And this brings us to a good point that we can talk about in regards to front end versus backend language. Front end versus back end languages. And what we're talking about here are back end languages, right? PHP, which is a programming language we'll discuss in the class this semester. Perl and Python are back end languages. A back-end language needs to be processed by the server before being sent out. Right? So our back-end language is processed by the server. Because the back-end language itself has to be interpreted. Right? It has to be read by a computer and changed into something that can be transferred along HTTP, our hypertext transfer protocol. Right? Because our HTTP could only really translate certain packets. Right? And these packets are primarily going to be HTML, our hypertext markup language. And so in general, our PHP, our Perl, our Python, that's not understood to go across HTTP, so our server will interpret these languages, turn them into HTML, and then send them to your browser. And so if we were to look at something like clevelandcc.edu, clevelandcc.edu is built as a WordPress site, and WordPress utilizes PHP as a back-end language. But if you go to clevelandcc.edu and you right-click and you inspect the code, all you see is HTML. You don't see any PHP. And that's because before that website was sent to you, all of that PHP was converted to HTML by the server and then sent to you through hypertext transfer protocol. Right, our front-end languages, on the other hand, they're things like HTML, CSS, and JavaScript. HTML, CSS, and JavaScript. Right, and these are front-end languages. And so front-end languages are actually rendered on the front end. So back-end languages are interpreted by the server. Front-end languages are rendered by your browser. And we'll get into this a little more in just a little bit, right? As we're talking about the process of you know, what happens when a website goes from the server to you. The fully graphical image that you see before you is not what the computer sends. Right? Basically, all that can be sent along hypertext transfer protocol in the packets is just basically computer language. Right? So essentially what's happening on the back end is the server's looking at the files. If there's any back-end language present, it's taking that back-end language and it's converting it to HTML. Then it's sending it as packets through the internet. It's just basically just making a copy of the file. Right? Like, so if you've ever had problems with cache, for example, right? You've had somebody tell you to clear your cache and see if it resolves an issue. Right? That's because the website that you have, that you actually see on your computer, is cached, meaning that there was a file that was basically, there was a copy of the website sent to you by the server. And then when you get it, your browser looks at it and it says, oh yeah, I know all this stuff. I know HTML, I know CSS, I know JavaScript. So I can render it out on the screen for them. So none of the graphical things actually happen until it gets to you, right? Which is really what makes all of this incredible, right? It's just how quickly that a website can load on your end when all this is happening in the back end. And then the browser is getting the website and painting all the content and making it look the way that it needs to look. And so the your browser on your end, after you've requested the website, is actually what is rendering the HTML, rendering the CSS, rendering the JavaScript, and making it appear on your screen the way that is intended for you to see it. And so that was kind of an aside. We kind of got away from the idea of our LAMP stack, but I also said there was a MAP stack and a WAMP stack. Well, we said the L in LAMP, right, is our operating system. So what we've done here in these different stacks is we've basically just replaced the operating system. Right? So if it's not Linux, it could also be Mac, our Mac operating system, or it could be Windows. Our Windows operating system. And so this software in particular it's not going to be universal. It's not going to be the same on every server, right? Servers are going to look different and have different software on them based on the types of applications that are being developed and served from those servers. But in general, they're all going to have some kind of operating system, some kind of HTTP processing server software, some kind of database software, and a programming language interpreter for back-end code. Also, just as another aside, you might see our LAMP, MAMP, WAMP stack written as XAMP or *amp. And these are basically just catch-alls, meaning that it could be a LAMP, WAMP, or MAMP. It could be Linux, Windows, or Mac, just to kind of throw that out there as something that you might see as you're studying this sort of stuff on your own. To sort of demonstrate that different servers could have different softwares on them, I made this little chart. And this shows us two completely different sets of software. Right, on the left here, we have our LAMP server. We started looking at that on the previous screen. Right, we said Linux, Apache, MySQL, PHP. On the right, we have the mean stack, MEAN. Our softwares are in a bit of a different order here. Just so we can kind of make sense of an acronym, right? We have MongoDB. MongoDB is the database software in this stack, right? So MongoDB would be our equivalent to our MySQL. Express.js, well, that's going to be our equivalent to our Apache, basically here. Angular.js. Angular is a JavaScript framework. We don't cover Angular in our program. We cover React, but they're basically JavaScript. They're both JavaScript frameworks where if you learn one of them, you can figure them all out. But that's going to sort of take the place of our PHP here as our interpreted language. And then finally, we have our operating system, and this is actually a JavaScript-based operating system in Node.js here. And so that's going to correlate to our Linux there. Right, so these are different softwares, but they still generally perform the same purposes. The big difference here would be the types of applications that I'm serving from this server, right? Our LAMP server is something that you can build PHP applications on, that you can host, say, WordPress sites on, because WordPress is PHP on the back end. Whereas on the right-hand side with our mean stack, there's no PHP there, right? There's nothing to interpret PHP. My language interpreter is Angular.js, so it's interpreting a flavor of JavaScript that's meant for the back end. And actually, one of the interesting things here is that basically everything except for the database here is all JavaScript. So that's one of the interesting traits of JavaScript, is that JavaScript could be a front-end language or a back-end language, depending on application. Right? In this case, we have Express, which is a JavaScript-based HTTP engine. Angular, which is a interpreted JavaScript framework. And Node.js, which is basically an operating system that utilizes JavaScript, with some other stuff kind of thrown in there with it. Right, and then we have MongoDB, which is we don't have to understand what this means at the time, but MongoDB is a non-relational database, whereas MySQL is a relational database. So two completely different sets of softwares on two completely different servers, but they basically perform the same purposes. Right, and so this is not something that you need to know right now. This is just to kind of show you what makes a server special as opposed to a just regular computer. And it's just to help define and clarify some terms when it comes to working with servers going forward, because we will be. Now, the real meat and potatoes of this module is about how the website or file or whatever you're working with gets from the server to you. And so we can kind of start with a real high-level overview here, and we can kind of narrow it down a little bit. But the big thing here is that it starts with a request from your client, right? So if you're the client, what I can do here, let me pull over a browser window. I can make a request. So I can request to go to clevelandcc.edu. And I hit enter. And we can see clevelandcc.edu gets immediately pulled back. Right? And so when the website actually gets painted onto my screen here, that's a response. So that's the result of a response. Right? So I make a request for a website. The server sends me a response. And then there are a couple things that happen in the interim. Right? But one of the big things to kind of note there is just how quickly that web page loaded. And of course, since I'm on the Cleveland Community College website every day, I have a cached version of the site downloaded on my computer. Right? Because I've made requests for this site before. And so as I mentioned, when you make the request, the server actually sends you back the interpreted PHP, the interpreted backend language files as HTML, CSS, and JavaScript files. So it sends you a copy of all of these files to your computer, and then your browser gets them and renders them out on your screen. And so there's a lot of stuff going on in the interstitial. There's TCP/IP, which we won't get into here. I explained that a little bit in the module. There's DNS, which DNS is kind of interesting. I talk about DNS like, you don't say, oh, I'm going to 137 South Post Road. You say, I'm going to go to Cleveland Community College, right? So DNS would basically be like the physical address for a building, right? Every site has an IP address that is associated with it, and that IP address is hard to remember, right? Like, if we had to remember like 172.198.134.246, if we had to remember something like that for every single website we wanted to go to, that would be impossible. So we invented domain names, right? And domain names give us a mnemonic that we can use to remember, like clevelandcc.edu. And so there are DNS servers that basically keep the pair of the address, of the IP address, and the domain name together. So it knows that, if you request clevelandcc.edu, what you're looking for is at this IP address. Right? There are actually domain name server vulnerabilities there. So if you're interested in cybersecurity, this is one interesting thing that you could potentially have to worry about in the future. Right? We have these sort of man-in-the-middle attacks. Right? To where if I can compromise a DNS server, then I can basically change the IP address that is associated with a domain name for anyone who is requesting that site through a certain DNS server. Right? So when I request clevelandcc.edu, it goes to the domain name server. The domain name server looks at its address book and it sees, clevelandcc.edu is this IP address. Sends the request to that server with that IP address, and then that server sends back the files. But if I were able to get into a DNS server and change those associations, I could basically send anybody who is sending a request to clevelandcc.edu to any site I wanted to send them to. Even ones that are, filled with malware. Right? So they think they're going to go to a site that they know and that they're familiar with, but then they get railroaded and end up with malware, end up with a bad time, right? And so securing a DNS server becomes of the utmost importance with that. HTTP, that's our hypertext transfer protocol. This protocol defines a language for clients and servers to speak to each other, and that language is HTML. Right? That goes back to why we don't get PHP files on our computer, right? We're not sent PHP files. Part of that is for obfuscation reasons, right? Like we can talk to databases and talk to other backend processes in a more secure fashion by using backend languages that convert a specific backend code into HTML before it's sent. But it's also because of the protocol that it's sent along, the hypertext transfer protocol. And that's defining our HTML language. So, let's get into the nitty-gritty here, and let's kind of draw a pathway that things take. And this is basically what's going to be expected of you for your lab assignment, is to kind of draw this pathway. And you can approach it from a different angle if you want. You can add things. You can add a little bit of context. But we basically want to make this as simple as possible here. So I'm going to sort of go through that process. You're being asked to draw a diagram that's going to be similar to this. And explain kind of the different steps, and that's your lab assignment for the module, is to, take a picture of that with the explanation of all the steps, send it in, and that's what we're doing. Right? So I'd like to do that, just kind of explain all this to you. So we start off on our computer, right? Here is you. And here is your computer. Some high fidelity drawings here. Right, here's you and here's your computer. So you make a request. And you'd say, I'd like to go to Cleveland cc.edu. And so especially if I've never been to clevelandcc.edu before, I need to know the address for clevelandcc.edu. Right? So my request for clevelandcc.edu is going to be sent to a DNS server, our domain name server. And it's going to look it up and it's going to send me some sort of IP address. Back. So it's basically like I'm kind of throwing it out there, especially if I've never been to the website before. I'm kind of throwing it out there and I'm kind of saying, hey, where's clevelandcc.edu? What's the address for that? Right? I've basically put it in a GPS here. I put it into Waze. Thanks, Don. I've put it into Waze and I've asked for the address, and it sends me back some IP address. And then so with that, my computer then sends out this message to that server that has that IP address. And I'm basically saying, hey, give me files. Give me the files for clevelandcc.edu. Give me the files for this address. I want to be able to see this website. And so now I have this request in with the server. Right? We can kind of think about this like we're at a restaurant, right? Like we're even using the same term server, right? You give your request to the server and you say, I want a hamburger. The server takes that request back to the kitchen and cooks up the hamburger, right? So that's what happens here. So once you've requested to the server to give you the files, it's got to prep the files. So in our kitchen example, right, they're going to take the burger, they're going to cook it, they're going to assemble it, they're going to put all the all the condiments and all the vegetables and whatever you got going on your burger. They're going to prep your burger back in the kitchen. And in our example here, what they're going to do is they're going to take the back end files, run them through that data cycle to convert data into something important, and kind of convert them into things that can be passed along to our user via the hypertext transfer protocol. Right, so our server takes these files, it runs them through all the processes it needs to run them through, and does its thing. And so once these files are ready, once they've had the opportunity to cook and turn into these front-end files, then our server basically tells our computer, here you go. Right, so our computer just gets files, right? Our computer just gets files. And then our browser takes those files and renders them into the site that we see. So if we kind of number this, right, and get all of our steps here, we're saying, give me files, or we're saying, where's clevelandcc.edu? Our DNS server says, oh, clevelandcc.edu is at blah, 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 blah IP address. Okay, well, let's go to that IP address and tell them to give me the files for the site. Okay, so then it preps the files. Right, so let's prep those files. That's going to be 4. It's going to send them back 5. And it's going to render them 6. And that's kind of my simplified version of what's happening when you request a website. Especially when you request one for the first time. Like after the files are cached, they're going to be in the cache until they expire. So things are going to happen a little bit differently from there. Right? Because basically you already have the files, so it just pulls them up to where, you already have them on your computer. So with that, I mean, you're basically just kind of doing if the files already exist in your cache, you're basically just doing this part. But if you're requesting the files, then we go through the whole thing here. And so I think, one thing that's pretty interesting, and I think it's probably the most important thing for web developers, right? And if we're looking at sort of back-end development and things like that, like step 4 here is super important, right? When we get to talking about PHP later on in the summer, the back-end portion here is really important on what's going on as these files are being prepped and converted from PHP to HTML becomes super important. But just in general, and what becomes the most important to us first is what's happening here when we get to the render. Because our browser actually determines the order in which things load, which is important, right? Anything that you do, order of operations becomes important. Right, and so since the primary thing that's sent across HTTP is HTML, that's what our browser gets first. Our browser gets the HTML first. And one of the things that we'll look at when we get into HTML and CSS is that when we start, and JavaScript, is that when we start to use these different front-end languages together, we have to add a request for these front-end language files in our HTML file. Right, so our HTML file comes first, and then as our browser is rendering the HTML file and reading the site, it will come across these different requests to different files. Then it'll basically kind of do at least part of this process again, right? It'll send a request to the server to get the CSS file. It'll send the CSS file back, and then it'll render the CSS file or the JavaScript file, and it'll get it back, and it'll implement the JavaScript file. Right, but where the requests for these files come from are inside of the HTML. Right, and so that gets back to that HTTP we were talking about, and how basically HTML is the only thing that really travels across HTTP. Our hypertext transfer protocol transmits our hypertext markup language. Right, which makes a lot of sense. So our HTML comes first, and then all the other files that are called in our HTML get requested as our browser hits them when it's reading through the HTML file. So everything goes top, bottom, left to right. So as it hits a request for a CSS file, it'll reach out and grab the CSS file and bring it back. As it hits a JavaScript file, it'll reach out and grab a JavaScript file and bring it back. Right, because that package is going to be there, and it's going to, need all these things for the whole site to run. And so something similar to this is what I'm going to be looking for your lab assignments. Right, I just want to see that you kind of understand the basic processes behind, what's going on when you request a site versus when you get it back. Right, and this process is really watered down and maybe even oversimplified for a little bit, but it's really, for our purposes, with where we're at, it's really kind of all we need to kind of understand. Like I said earlier, especially if you're in networking or cyber, you're going to get into these processes a whole lot deeper. And so we really don't need to kind of overcomplicate them here. And so we're just going to kind of keep it simple. Just, if you just kind of show me that you understand and you kind of know what's going on, everything's going to be all good. And so that brings me, I think, to the end of what I want to talk about today. Once we have this module behind us, it'll basically have, all the we'll be kind of done with all the background. So as we're kind of wrapping up here, if anybody has any questions, feel free to send them my way. Put them in the YouTube chat, or if you want to send them via email or Teams, you're welcome to do that as well. I am monitoring those. We'll have this recording up as soon as possible. If you're watching the recording and you have questions, feel free to send me a Teams message. Feel free to send me an email. And I will do my best to answer them. So we'll just hold a minute here just in case there are questions. All right. Well, with that being said, seeing no questions, we'll just go ahead and wrap up here. If you think of a question later, feel free to send it my way. Thank you for watching, and we'll see you next time.